Number 87 is a common ion problem. We have the system where calcium phosphate, which breaks up into 3 calciums and 2 phosphate ions, has the KSP, concentration of calcium ions, cubed times the concentration of phosphate ions squared, and instead of just in pure water, they're asking how much of it will dissolve in 0.20 molar phosphate. So from another source, I think it's sodium phosphate, we have 0.2 molar phosphate ions already present. So when we have a common ion problem, we use an ICE table. So we're going to have calcium ions, phosphate ions, and our initial, change, and equilibrium. Initially for calcium we have 0, but initially for phosphate we have 0.20 molar. The change, we always go back to our original balanced equation. The change when we drop this in, that for every one of these that dissolves I'll get 3 calciums, so that'll be plus 3x, and I get 2 phosphates plus 2x. So at equilibrium I will have 3x of calcium and 0.20 plus 2x of phosphate. And because this is going to be such a small change when this 2x is there, for this one we can disregard the 2x. Compared to the 0.20, this 2x is so tiny it doesn't make a difference. This counts 3x because it's the only source of calcium. There is nothing already there waiting for it. So all I need to do is plug these into the KSP expression. We know that KSP is 1.3 times 10 to the minus 32. And that's going to equal concentration of calcium, 3x, cubed, because we take the concentration and we cube it, times the concentration of phosphate, which is just 0.20 because we ignore the additional amount, and it gets squared. So now it just takes a little bit of algebra where 1.3 times 10 to the minus 32 divided by 3 cubed would be 27 times 0.04. 0.2 squared is 0.04. So I'm dividing this side by the number parts on this side. I take the cube root of the whole side, and that equals x, which equals 2.29 times 10 to the minus 11. Remember back in problem 83b we just found the solubility of this in pure water, and it was 1.6 times 10 to the minus 7. So our solubility has decreased, which is what we expect in a common ion problem. Solubility decreases if there's a common ion present. And this is, of course, moles per liter of calcium phosphate.